Okay, I'm going to talk and I want you to watch and not write. Okay, so a 2D object. You got your objects that are flat. So I'm going to talk to you about, let's say, a rectangle. Okay, so a rectangle is a shape that's a 2D object. Let's pretend this side length is 6 and this side length is 2. What is the area of that object? 12. Okay, let's use a scale factor of 3. Does that mean something's going to get enlarged or reduced? Enlarged. So I'm getting a bigger object. What is this side if the scale factor was 3? 18. And then this side would be 6. What is the area of this? You might need your calculator.
108.
108. Okay. This sides tripled. The scale factor of the sides was 3. So I'm going to call that the linear scale factor. Okay. What happened to the area? Is that 3 times bigger? No, that's not 3 times. What'd you say?
Cube. It's cube, right?
I think you were going to say something right before. What were you going to say? How many times bigger is that? What is 108 divided by 12? It's 9 times bigger. So what's the relationship between the linear scale factors and the area scale factor?
The linear squared.
The scale factor will be the linear scale factor squared. Okay. By the way, I have this written down on that one paper for you, like not the exact same measurements, but that paper I gave you yesterday. Okay, let's go with okay, this is a 20 by a 5 rectangle. What's the area of it? What's 20 times 5? What's the area? 100? Okay, I'm going to do a linear scale factor of 0.2. 0.2 is my scale factor. Will my object enlarge or reduce? Reduce. Okay, what's the new side? 20 would turn into anybody know? 20 times 0.2. You can do it on a calculator, that's fine. 4. And 5 times 0.2 is 1. What's the area of this? Just 4. Okay, so what's the scale factor? So remember, scale factors are always new divided by original. So if our new area was 4 and 100 was our original area, 4 divided by 100 is a scale factor of 0.04. What do we know? Did that have the same relationship? Yeah. So they're not going to have the same scale factors when you compare linear with area. The scale factor will always be in a relationship of getting squared. Okay? Okay, let's do 3-dimensional. So 3-dimensional, Do we understand three-dimensional objects like that as a cube? A sphere, a cube, something like that. Okay, let's go 3 by 5 by 4. Can we get the volume of that cube? Do you know how to do a volume of something like that? Length times width times height. So 3 times 4 times 5 makes a volume of 60. Okay, let's linear have a scale factor of 2. Is that going to enlarge or reduce something? Enlarge. Okay, so I enlarged it and my scale factor was 2. So the 5 will turn into a 10, 6, and an 8. So what's the volume of this shape? 480. Well, that didn't double. Okay, my sides doubled, but the volume did what? What happened? So I'm going to divide those to see what happened. So the new volume divided by the original volume is 8. So the scale factor of the volumes is 8. Okay. If the sides double, but the volume is 8 times bigger, what's that relationship? It will be the linear scale factor cubed. Okay? Cubed. Not timesing by 3, but cubing it. Okay? Okay? Does this make sense? It's nice to see visuals so you can kind of make sense of it. Okay. Here we go. Our examples. A rectangle is 5 by 9. You don't have to draw. I'm just a drawer. What's the area? So 45 centimeters squared. Using a scale factor of 2, what are the dimensions of the new rectangle? So if I scale factor the sides by 2, my new rectangle will be 18 centimeters by 10 centimeters. What's the area of this one? 180 centimeters squared. What do you know about the scale factor of what happened to the areas? How many times bigger did it get? So I'm going to go new volume, or not volume, let's call that an area, how about? New area divided by original area. So I noticed that my area got 4 times larger than its original. So the rule, what do you notice? Let's write a rule. So here it is. Bless you. The area scale factor equals linear scale factor squared. So whatever I'm doing to the sides, the area will be squared that relationship. Okay, you're ready. A computer screen is 35 by 55. Centimeters. And it gets projected onto a whiteboard screen, and now it has an area of that. Determine the dimensions of the whiteboard. Okay, so I'm just thinking real life, a computer screen, when I project it up there, it's going to get bigger, right? So I'm going to be blowing something up, and then I know that this is the area. Okay, so that's the given info. That's what I've been given. So I've drawn that out. I think it will be helpful if we could calculate that area because we have those numbers. Okay, so here I go. New area divided by original area. New area divided by the original area. So I'm going to get those numbers. Okay, so my thinking is the screen area is 3.76 times larger in area. Okay, here's what I'm going to do. Our linear squared will be that. Our linear squared is that. Our linear scale factor squared is that. So what do I have to do to work backwards? Square root. Okay, so the sides are increasing by 1.94 times bigger. Okay, so that's what I'm going to do. So give me the new dimensions. So I need 1.94 times bigger. Okay, so that one I had to work backwards. This time I gave you the two areas, and you had to work back to the linear. So before we had squared, now I'm just working backwards, so I'm square rooting.
Is that underneath S of area? Is that like a square root symbol? Is that a divide symbol?
This is a square root symbol. Like this one you're talking about?
Yeah.
Like it's a square root. Yeah. Because it's me showing you square rooting, that's squared. I'm getting rid of the square root squared, getting rid of them. Okay, a cube measures 8 by 8 by 8. Determine its volume. What is the volume of that object? So what is 8 times 8 times 8? So 512 centimeters cubed is the volume. Using a scale factor of 1/2, so I'm going to say the linear scale factor is 1/2. Okay, I'm putting an L beside that, because that's the linear is 1/2. So obviously my cube is getting smaller because it's 1/2, right? It's less than 1. So the new dimensions, 4 by 4 by 4. What is the volume of that? What's 4 times 4 times 4? 64 centimeters cubed. Okay, so to get scale factors, you always do new divided by original. So what is the new volume divided by the original volume? So what is 64 divided by 512? So the relationship is cubic, a half cubed. 0.5 cubed is 0.125. So that's where that's coming from. Cubic relationship. Those scale factors are getting cubed now. So let's go. The volume scale factor equals linear scale factor cubed. That's the rule. So are we going to remember these two rules? So there's my two rules. The area was when the linear scale factor was squared. Volume, you got to cube it. So working back, what's the opposite of cubing something if some of the problems have to work back from? What's the math operation that's opposite of cubing something? Do you know that? Cubed rooting. Cubed rooting? So we're going to have to probably find those in our calculator. Let's see if we tackle one of those problems. Okay, a square is 6 centimeters high. It needs to be enlarged and I need to enlarge it to cause that 6 to go up to a 15. Okay, what scale factor did I use in that enlargement? So what are you going to do to get me that? The new side divided by the original. The new side divided by original side. So my object is getting blown up, enlarged 2.5 times bigger. Okay, remember making sure your scale factor is showing you is it enlarging or reducing. Make sure you're understanding that that number needs to be either bigger than 1 or smaller. Okay, how many more times bigger is the area? So what am I going to do to understand the differences in the area? I'm going to take that and I'm going to square it. So the area will be 6.25 times bigger than the original area. Okay? I was just doing this one. This question. How many times larger is the area? Okay. Now it says how many times larger is the volume. Obviously I'm not going to do a volume with a rectangle. So, or a square. Sorry, that was a square before. So let's just pretend this last question we're going to be dealing with a cube. So we're going to pretend if we had a 6 cube side or a 15 cube side, how much larger is the volume going to get? So 2.5 cubed is now what I'm going to do. So the volume scale factor Okay, so that's the scale factor for the area. So I'm going to go ASF VSF. This is the area scale factor, and this is the volume scale factor. Okay, so I'm just taking the sides. What am I doing to the sides? I'm squaring that for area. I'm cubing it for volume. Okay. I feel like this next question is the exact same. So let me just try a different question here. Okay, here's my question for you. Okay, I have two rectangular prisms. Okay, they're not exactly cubes. This isn't a 16 by 16 by 16. All I gave you was the height. I want to figure out that height. The volume on that shape, the volume of that shape, I was given. Okay, you ready? What is the scale factor for those volumes? So I'm going to go new volume divided by original volume. So 4.32 divided by 160. Okay? So my scale factor for the volumes is 0.027. Okay. So that makes sense. New divided by original. That's all I do every time. New divided by original. Okay, what is the scale factor for the linear then? 0.3. What do we do to get it? So we take the volume scale factor equals the linear scale factor cubed, right? So to get this, we're going to have to cubed root. So the volume scale factor cubed root will equal the linear scale factor. So can you find your buttons on your calculator? I'm going to show you what to do on mine. So on mine, I have to push 3 and then this button called the any square root of 0.027. Okay, cubed root. I'm going to walk around, see if you... Okay, so we get the cubed root of is 0.03. So that is the linear scale factor. So the final answer is, what height is this shape? So you're going to go 16 times 0.3. So 4.8 centimeters is the new height, because it reduced, right? 0.3, scale factor, reducing something.